So let's talk about blood groups. Blood groups are nothing but different types of surface markers that I have on the red blood cells of an individual. Each individual will have a specific set of surface markers on their red blood cells that gives the type of blood of that individual. So this individual here has these proteins here represented by the red arrow that give an identity to those cells. Another individual will have a different type of proteins on the surface of the red blood cells. Therefore, I have a different type of blood. Now, these surface markers are nothing but antigens. So the name antigen describes these proteins that are on the surface of these red blood cells. Turns out, though, that we have over 30 groups of blood. So I have the not so popular M&S, Kells, Duffy, that are different types of blood, and the most popular ones, the most common ones that everybody is familiar with, which are the ABO cysteine and the RH cysteine. So the person is A positive for RH positive, or AB negative, meaning that they have the blood group AB and they are RH negative. So why are those more popular than the other 28 groups that we have out there? Well, because the ABO cysteine and the RH are the most likely to cause transfusion reactions, meaning that you need to know the identity of the blood that you're getting for these specific groups, ABO and RH, before you can donate blood or you can receive blood. So the ABO cysteine is also characterized by the presence of antibodies in the plasma. So on top of having the antigens, the ABO cysteine will also have these antibodies in their plasma. And the person is pretty much, from the time they are born, they start developing that. The way these antibodies arise in the blood is not well understood. But let's assume here now that a person that is these different types of blood on the ABO group will have an antigen and a corresponding antibody associated with them. So based on that, I can create a table here, a very simple table in which I give the blood type in one column, the antigen in another column, and the antibody on the other column. So if the person is of the type A, that means that he has the antigens of the type A, but he also has the antibodies of another blood, an antibody that will bind with the red blood cells of the type B. So that person has anti-B as their antibodies. So a type A person has antigens, surface markers of the type A, but has antibodies of the type B, anti-B. So a type B person has essentially the opposite of that. He has the antigens of the type B, but he has the antibodies of the type A. So a person that is AB, you can probably deduct what they have. That means that they will have both antigens A and antigens B, but because he has these antigens, these surface markers, he cannot have the antibody that will react with it. So that person will have no antibodies whatsoever. So let me just erase this. Let's move on, no antibodies. And a person that is type O, also known as type 0, 0 for no antigens. No antigens on this person. He will have no antigens, but will also have both antibodies, both antibody A and antibody B. So let's see how the transfusion reactions will occur. So in this first example here, I have a person that is of the type B donating blood for a person that is of the type A. So the person that is donating the blood has on its cells the antigen or the surface marker of the type B. And that is a problem because the person that is the receiver here, which is the type A person, will actually have the antibodies for that type B. So the person that has the plasma with anti-B, the antibodies on their plasma will coat the donor's blood. So that person has a reaction and will react to that type B blood. The name of this reaction is actually called agglutination, which is nothing but the clumping of the red blood cells of the donor with the antibodies of the receiver. And that causes a problem. It causes a reaction. You simply do not accept that blood. same way your antibodies fight off disease, in that case here, the antibodies of the donor, the antibodies of the receiver are fighting off the blood of the donor. On a different scenario here, I have the type A person donating type B, and the same thing will happen. The only difference here is that the name of the actors are reversed. This person here, the donor, has the antigens of the type A, and the receiver has the antibodies of the type B. And I also have a agglutination reaction. Now, very interesting though, what's going to happen when somebody is of the type AB and receiving blood? So they have no antibodies, so they cannot react with anything. So sure thing, when a type A person donates blood to a type AB, that means that that person will not react to that because it doesn't have the antibodies. Same thing would happen if I was the type B donating blood to a type AB. I do not have the antibodies, therefore I don't react to any blood that is given to me. So a person that is of the type AB is called the universal receiver because it can receive blood for any blood group of the ABO system. So on the type O though, the things are slightly different. So in that case, a type A person is donating blood to a type O. Unfortunately though, the receiver here have both antibodies, and I'm going to have that agglutination reaction happening here. So agglutination reaction will take place for that as well. So, and if I'm dealing with a type B donating blood to a type O person, agglutination will also take place because of the antibodies that we have. And if a type AB is donating blood to a type O, we'll also have agglutination reaction happening here. So for all these three scenarios here, I'm going to have agglutination taking place. Now, what happens when blood type O is given to type A and is given to type B and is given to type AB? Let's see what happens now. Well, when a person type O donates blood to a type A, it's donating a red blood cell that has no antigens associated with them. So because it has no antigens associated with them, the receiver here, which is the type A person here, which is the receiver, the antibodies that is present on the receiver's plasma will not react to those. So that person, in all scenarios here, gets the blood just fine. There's no agglutination taking place when a type O is donated to a type A, when a type O is donated to a type B, or when a type O is given to a type AB. Because of that, we call type B the universal donor because of that. Because anybody can receive blood of the type O. Obviously, and I didn't mention here, but it goes without saying, that a type O can donate blood to another type O. But that's the only case that I'm going to have that situation. And in the other scenarios, type A can donate blood to a type A, type B can donate blood to a type B, and type AB, of course, can donate blood to a type AB. I just didn't draw those here. So, now the next step then now is understanding the RH system. I have over 50 subtypes of RH group. So we normally deal with RH negative and RH positive, but that is referring to just one subtype of the RH group. The RH group that is most likely to cause transfusion reactions is called the antigen D or antigen D. In that case, the antibodies are not initially present on plasma. So different from the ABO system in which the person is pretty much born with the antibodies in plasma, in the RH group, they are not initially present on plasma. So that would change things slightly here. So in that case, here I'm drawing a person that is type A positive, and all I'm doing is just drawing the antigen D here on the surface of these cells. So the person that is RH positive will have the antigen on their surface, but will not have any antibodies, or at least not initially will not have any antibodies present on the plasma. So there's no anti-D. If a person is B negative, that means that he has no antigens on their surface, And if he's AB positive, then there are antigens of the type D are present again, and I can draw all possible combinations of that. But this should clarify it enough. So when the RH group is important in blood transfusion, if the antibodies are not initially present, when would they become important, and why this is a type, the RH group, it's still likely to cause transfusion reactions? Well, there are certain circumstances in which that occur. Only a RH negative person will develop antibodies, because if an RH positive person develops antibodies, it will attack its own blood. So the only scenarios in which I'm going to have the development of antibodies is when the person is Rh negative, gets exposed to an Rh positive group. So the antibody that we're dealing here, it's called the anti-D, and this anti-D will only occur, will only be expressed in a Rh negative person once that Rh negative person is exposed to the Rh positive group. So that doesn't happen normally in life. There are certainly special scenarios in which you're exposed to Rh positive group that makes you develop these antibodies. So special scenarios would be doing a blood transfusion. I am Rh negative. Somebody donates a blood that is Rh positive. I'm going to develop these antibodies. Or once they have a leak of Rh positive blood through the placenta, mom in that case is Rh negative. Mom in this case that we're dealing with here, it's Rh negative, but baby, it's Rh positive. So the baby's blood leaks through the placenta and exposes the mom to the Rh negative. The result of this is that mom starts to develop the antibodies for that baby against the blood of that baby. That normally does not cause a problem. Normally does not cause a problem in the first pregnancy because there's not enough time for the mom to produce enough antibodies that will fight off the baby's blood. But on a second pregnancy that mom again gets exposed to a second baby that is of the Rh positive group, she will already have these antibodies present in plasma, and guess what? It will fight off that baby's blood. So once that happens, again, I'm going to have the same reaction that we had before happening. On a second pregnancy, agglutination takes place one more time. So the name of this, it's a very interesting name. The name of that is called erythroblastosis fetalis. So huge word, erythroblastosis. Fetalis, and fetalis for fetus or baby. Huge word to describe something very simple. I'm going to have the blast, I'm going to get a different color here. I'm going to have the blast of the red blood cells, in red is called erythro, of the baby. The blast of the red blood cells of the baby. So when that happens, when a mom is Rh negative, when a mom is Rh negative and she gets exposed to Rh positive blood of the baby, of baby number 1 and on baby number 2, that's when I have erythroblastosis fetalis. That's when the mom already has a build up of antibodies on her own body, and those antibodies will agglutinate with the baby's Rh positive group. That's a very short and sweet explanation of these, and I hope you guys like it. I hope you guys subscribe it and share that with your classmates as well. Thank you so much.